Hello, today we'll discuss the rectifier. So we know the diode is a device that passes current in only one direction. That is when the positive terminal of the battery is connected to the anode and the negative terminal is connected to the cathode of the diode. At that time, the current passes through the diode, and when the negative voltage is applied to the diode, it will not conduct. So the diode is a device that passes the current in only one direction, and such a device is generally used in networks, and they convert the alternating current into the direct current. So the diode is a device that currents passes current in only one direction. Okay, so therefore we'll use the diode in half wave rectifier, which convert the alternating current into the direct current. Therefore, first is the half wave rectifier. In half wave rectifier, we use the diode, and therefore this is the alternating supply voltage. This is a symbol of diode, and this is the resistance. You can say it is a load resistance, and this is the V is equal to Vm sin omega t. This voltage is applied to the circuits, and therefore this is the R, and voltage across the resistance is VR. Voltage across the diode is Vd. Okay. So the while alternating current and voltage play the leading role in most of the electrical and electronics devices, and in many circuits we require only the unidirectional current and voltages, and therefore process of obtaining the unidirectional current and voltages from the alternating current and voltage is known as rectification, because we get the voltage supply where actually alternating voltage supply we are applying to the devices. But there are the some electronic devices which requires only the unidirectional voltage, means the voltage only in the one direction, or the current in only in the one direction, like this. So the process of obtaining the alternating voltage into this is unidirectional voltage, this is a bidirectional voltage, because we are getting the voltage on in positive side as well as negative side. Here in this side it is positive, in this side it is negative. So here we are getting the voltage in both the sides, and but here we are getting the voltage in the positive side. In negative side we are getting the zero voltage. So this is the, we can call it this voltage is the unidirectional, because they are only in one direction, and this is a bidirectional. Okay, so in this way the diode here we have to use as a rectifier, and therefore the device that makes such a process possible is a diode. Okay, and therefore we can supply the voltage like this. So this is the voltage and current we are applying. So obviously the voltage is alternating voltage, we are applying the voltage to the resistor through the diode is like this, and the current is we are getting like this current. This is a current. So this is a voltage and this is the current. So for positive half cycle we are applying this voltage, negative half cycle we are applying the voltage, but the whole current during the negative half cycle will be this, and this is the voltage. So we are not getting the current here. Current is 0, whereas we are getting the same voltage. Okay, but the voltage which will get across the resistor is like this. So we are getting the voltage across this resistor. So we can call this as a VR, and the current across the resistor is also, we are getting the current I across the resistor. But now the voltage across this resistor will be 0 during the negative up cycle. So this is the VR as well as this is a I. We are getting the, when applied voltage acts in the forward direction, there is no voltage drop across the diode. There is no voltage drop across the diode, and the current flows without any uh, opposition. Okay, so we'll get the current flow in the register also. That is, this is a current flowing in the register during the positive cycle. But when during the negative, this negative half cycle, we are applying the voltage in the negative direction. At that time, the voltage drop will be there across the diode, and no current will flow through the resistors, and therefore this is the voltage across the resistors, and the current flowing through the resistor will be 0. So this is the diagram. So it is possible to obtain the rectification by means of a single diode, and the current can only flow through the diode in one direction, and thus the load current can only flow during the alternate half cycles. Okay, so alternate half cycle means this is the load current, and during the half cycle it is now 0. Again, next half cycle, during positive half cycle, we'll get the voltage across the, like, we'll also get the current like this same. So these current and voltage, they are unidirectional. Okay, and the load current and voltage drop across the load is unidirectional. So V is the, here it is the instantaneous supply voltage. VD is the instantaneous voltage across the diode. Across diode. VR is the instantaneous voltage across the load resistance. Instantaneous voltage across load resistance, and I is the instantaneous current, instantaneous diode current. So by using the Kirchhoff's voltage law, what is the total voltage V, which we have applied across the, this circuit is nothing but voltage across the diode plus voltage across the resistance. So what is the voltage across the diode? We can say it is a VD, and what is the voltage across the resistance? It is I into R. Suppose we have to find I, R is equal to V minus VD. Okay, therefore R, we have to find, here it is a current I is equal to, this is a V by R minus VD by R. Okay, so this is the current, diode current will get, and therefore it indicates that VD has a small value during the positive half cycle when the diode conducts, but it is equal to V during the negative half cycle. Okay, therefore, if the supply voltage is V is equal to Vm sine omega t, then I is equal to V by R. V is nothing but Vm sin omega t by R, which is equal to V by M is nothing but Im sin omega t. This is during the positive half cycle. During positive half cycle. Okay, so the mean value of the current is nothing but the direct current. So the mean value of the current, if the mean value of the current is equal to IDC, because it is a direct current, unidirectional current. We are getting the current in only one direction. That's why we can call it as a IDC. Therefore, then IDC is equal to 1 over 2 pi, and this is a 0 to pi, because we are getting for a half cycle only. So Im sin omega t d omega t. Okay, so it is a Im outside divided by 2 pi, and integration of sine is minus cos omega t. The limit is 0 to pi. Limit is 0 to pi. We have to just substitute the limit, and therefore we got here Im by 2 pi minus cos of pi, means it is 180 degree, minus into minus of, it is a cos of 0. So it is a Im by 2 pi cos minus 1, it is minus 1, and this is the minus and minus of cos 0 is 1. Therefore what we get here, we get here, it is a Im by 2 pi 1 plus 1 is equal to 2 times Im by 2 pi. 2 will get cancelled. Therefore we get the direct current, that is the mean value of the current, IDC is equal to Im by pi, and this is equal to 0.318 Im. So this is equation number 2, and therefore we can similarly we can calculate the RMS value of the current. The RMS value of the current is IRMS, then with IRMS, and IRMS is equal to square root of 1 over 2 pi 0 to pi Im square sine of omega t square into d omega t. Therefore we have to take this Im square by 2 pi outside this integration, and therefore in the integration to substitute the formula for sine square omega t is equal to 1 by half into 1 minus cos 2 omega t into d omega t, and again we can solve this, is equal to under square root of Im square by 2 pi into half into constant we have taken outside the integration. So integration of 1 with respect to the d omega t is equal to omega t minus integration of this cos 2 omega t is equal to sine. So this is a minus half. So it will be the plus sine 2 omega t 0 to pi So if you solve this, m square by 2 pi into half, so it is omega t. So we have to substitute here. Sine of 2 minus, so we have to substitute here 0 plus half into sine of 0. Therefore, we can write here, so it is a m square 2 pi into up to, so it is a to sine of 180 degree, it is a 0 minus sine 0 is also 0, and therefore so actually we have to substitute omega t is equal to pi. Here we have to substitute here, it is a total value is, instead of this we have to substitute omega t is equal to pi. Therefore what is remain there? It is im square by 2 pi into half into pi. So this is becomes im square by 4, pi is cancelled, and therefore what we get here, this is im by 2. So IRMS is equal to im by 2, and therefore this is equal to IRMS is equal to 0.5 into m. So this is the RMS value of the current. Similarly, we can obtain the mean value of the load voltage and RMS value of the load voltage. So mean value of load voltage and mean and RMS value of load current just like what we have derived in the derived for the current. We have to write VD is equal to same, that is a I Vm by pi, and here RMS value Vrms is equal to Vm by 2. And since the production of direct current from AC supply is the object of the DC current, therefore efficiency of the rectifier circuit is defined as efficiency of a rectifier circuit is defined as power in the load due to DC component of current, and this is a total power dissipated in the circuit. So we can write here DC square by R. This is a DC component of the circuit. This is I RMS into R. If you substitute this value, IDC is nothing but Im by pi square into R, and this is Im by 2 square into R. So here we will get this 40%. So efficiency is equal to 0.04. Thank you very much.